In this video, I'm going to try to teach you some more about gases, specifically the pressure that gases exert. I mean, gas seems like it's an invisible, intangible thing, like it barely even exists, but if you put it into a balloon, it'll push back, right? You squish the balloon, it'll bounce back at you. Also, tires are just full of air, but they can still manage to hold up the entire weight of your car. So how does that work? How do gases exert force? That's what this is going to be about. Okay, so before I teach you a way to visualize and understand the mechanism by which gases exert pressure, I'm going to have to remind you about the kinetic molecular theory. So there are 5 postulates of the kinetic molecular theory, but basically it just implies that gases are tons and tons and tons of atom-sized bouncy balls bouncing around a container. They go faster if they're hot, and they go slower if they're cold. Now, think about this. When a particle hits the wall of its container, it's going to bounce backwards. And in that act of bouncing, it's going to need to apply some force to the wall in order to change directions. Imagine you get hit with a baseball. It bounces back, and it hurts, right? So when particles hit walls and they change directions, they need to apply a force to do that. Every single time a particle hits a wall, it pushes it a little bit. Now, if it's the wall of your house, it probably isn't going to knock your house down because the walls are very strong. But if it's the wall of a balloon, maybe it'll push it out. That's why when balloons are very tiny, they're small. But as you fill it with air, these particles punch against the wall constantly. And as they do that, it expands out. So the pressure of a gas, the amount of force that it exerts on the walls around it, it depends on how often these particles hit the wall. If you hit very slowly, then there's not going to be very much force. But if you hit very quickly, there's going to be a lot of force. And it's going to push back with a lot of pressure. More collisions means more hits, and that means more pressure. That's what I want you to think about. The pressure that a gas exerts in terms of this picture of tiny molecular bouncy balls. Now let's think about some things that could affect the pressure that a gas applies to the walls of its container. And instead of showing you a lot of particles at once, like I've been doing, I'll try to show you only one so that you can focus on the relevant parameters, the important parts. Let's take this as our default case. There's a gas particle in a box bouncing around. Let's count the number of times that the ball hits the wall in 5 seconds. 1, 2, 3, 4, 5. Okay, so this is our default case. When we have a normal gas particle in a normal box, we're going to change some things about this box and see if there's more or less pressure that gets created. Let's investigate the effect of the container size. If a gas particle is in a smaller container, you think it's going to hit the walls more often or less often? Well, let's see. Let's put it in a smaller container and we'll see what happens. So let's wait for 5 seconds and count the number of hits in the smaller container. 1, 2, 3, 4, 5. It hit the walls more often, which makes sense because it has to travel less distance to actually get to a wall. So what we just discovered was that when you make a container smaller, the particles inside are going to hit the walls more often. And if you hit the walls more often, you're going to be exerting more force, which means that you're going to have more pressure. So this big relationship that I want you to understand from this video is that when the volume of a container decreases, the pressure applied by the gas inside is going to increase. It's going to get more pressure as you squeeze it down. This is why when you squish a balloon, it eventually pops. It pushes out with so much force that it bursts the rubber on the balloon. Vice versa, the opposite of this is true too. So if you increase the volume of a container, these particles are going to have to travel longer, and there's going to be less pressure inside. Okay, so we know about how volume affects pressure. Now let's investigate the effect of particle speed on pressure. And particle speed is basically the same thing as temperature. Let's make the particles in our box move faster than they were moving before. That means we're increasing the temperature. Let's see what happens. Let's count the number of hits in 5 seconds for this warmer container. 1, 2, 3, 4, 5. It hit more often. When you make the container warmer, the particles get faster, and they're going to hit the walls more often. This makes sense because they're moving faster. So even though they have the same amount of distance to cover, they can do that in less time. Big relationship number 2 about pressure. When the temperature of a gas increases and it gets warmer, the pressure applied by the gas also increases. So if you heat up a balloon, the force that that gas applies to the walls of the balloon is going to increase, and it'll eventually get bigger. That's a volume thing, but whatever. When the temperature increases, the pressure is going to increase because you have more particles colliding with the wall. Okay, finally, let's investigate the effect of particle number on pressure. And when I say particle number, I mean, what if you had 3 particles in the box instead of 1? How many more hits would there be? So let's add a second particle to our box, and we'll count the number of collisions in 5 seconds and see what happens. So let's count. 1, 2, 3, 4, 5. Once again, it was more than our default 1 particle in the box. That makes sense because we have 2 particles, so we would expect to have about twice the number of hits. When we add more particles, the walls get hit more often. And if they get hit more often, that means that that force is being applied more often, so you have higher pressure. So this is the third big relationship. When the number of particles in a gas increases, the pressure applied by that gas is also going to increase. Okay, we're almost done. I just need to give you some vocabulary. These are 3 facts that we now know about the world. When the volume of a gas decreases, so you squish the balloon down and the gas gets compressed, the pressure that that gas applies will get larger because you have these particles bouncing around in a smaller container and they hit the walls more often. The second fact we know is that when the temperature of a gas increases, meaning the particles go faster, the pressure will also increase. So if you have a balloon and you put it over a Bunsen burner or something that makes heat, it's going to expand because it gets bigger. And we also know that when you increase the number of particles in a gas, you're also going to get more pressure because there are more particles, so there's going to be more hits. These things are not exactly the same. So notice here, when the volume of a gas goes down, the pressure of the gas goes up. For these other relationships with temperature and number of particles, when the temperature goes up, the pressure goes up. Same thing with particles. When the particle number goes up, the pressure goes up. So we have 2 different categories of relationship here. Now, science vocabulary, you're going to need to know this if you are going to take any more science classes in the future. It's a very important concept. If 2 quantities move in the same direction, so increasing one of them increases the other one, like more money, more problems, more studying, better grades, we call that a direct relationship because increasing one increases the other one. If 2 quantities move in opposite directions, then we call that inverse relationship. So, for example, spend more time playing video games, get worse grades, something like that. It's an inverse relationship because when one thing goes up, another thing goes down. So, when the volume of a gas decreases, the pressure of that gas increases. That's an inverse relationship. Volume is inversely related to pressure. These are the 2 ones. When the temperature or the number of particles goes up, the pressure also goes up. So because they both go up at the same time, that means that those are direct relationships. So to summarize everything in one slide, volume and pressure are inversely related. Temperature and pressure are directly related, and particle number and pressure are directly related for a gas. If you can remember these 3 sentences, remember what they actually mean, and visualize in your head the kinetic molecular theory explanation of why these are true, then you will have gotten everything you needed to get from this video. I'll be very proud of you.